Good morning, students. So we are in the session 6 of work, energy and power topic. In Canada, we will continue with our discussion about the potential energy. Angalandi will also start the applications of the work energy theorem. Okay, so in a maximum questions we will get mostly from the applications of the work energy theorem. Okay, so that will take some time to cover. And we examples cover. Okay, so we are discussing about the potential energy. Potential energy means what? It is the energy associated with the state or configuration and solala. Okay, of an object relating to what? Taniya and the object relating to the conservative force. Okay, so relating to the conservative force. So how do we define? Negative of work done by the conservative force is equal to change in the potential energy. Relating the work done by the conservative force with the change in potential energy. Okay, so we have talked about the derivation for the gravitational potential energy at a height h. What is it? mgh, by using the surface of the earth as the reference. And the spring potential energy, when the spring is expanded by a value x or compressed by a value x, the value is half kx square. The reference will be the natural state of the spring. Natural state of the spring, we have taken the potential energy of the spring to be what? 0. Okay, so next we have looked at the relation between the potential energy and the work done by the conservative force. But we can also look at what is the relation between the conservative force itself and the potential energy. General relation. So the gravitational force ko illana spring force ko kadiyadu, it's a general relation. So what are we going to do? We are going to relate the conservative force value itself to the potential energy term. If you are having the conservative force which is F, okay, it may be the constant or it may be a variable. Because simplified gravitational force formula, it will be what? Constant. But a spring force will be variable force. Adhanala we will just keep it as what? Force. If we are giving a small displacement for the object dr, what is the small work done by the conservative force? F dot dr dana. This is what? The small work done by the conservative force for that displacement of dr. In this, right, the change in the potential energy nama u and edutha, change in potential energy also will be small. Adu nama eppadi represent pannala? Du and represent pannala. Okay va? So parunga, if look at the relation, what is the relation? Negative of work done by the conservative force means minus F dot dr, that will be equal to what? Change in the potential energy. So this is the relation between the conservative force and the change in the potential energy. This is what we generally call as the differential form and solu. Because you have the differential element. Adhanala we call it as what? Differential form of the relation. What is the differential form of the relation? Minus F dot dr is equal to what? Dr and so now what is it? The displacement that is given to that object. Whatever object we are applying the conservative force on, right? And the object of the displacement. Okay, in the expression I'm integrate panna. So if you do the integration from initial limit to the final limit, minus F dot dr, integrate panna, we will get what? What is this? This is going to give us right side like integral du and sonna small changes in the potential energy. That will give us what? Total change in the potential energy, which is u final minus u initial. So what is the integral form? So right side this is the differential form. So left side we are writing the integral form. What is it? minus integral a to b f dot dr. அப்படியே நம்ம அந்த எக்ஸ்பிரஷன் இன்டிகிரேட் பண்ண அவ்வளவுதான். ரைட் சைடில் வரும் du க்கு பதிலா delta u வரும். delta u means what? Final potential energy minus initial potential energy. ஓகேவா? So this is what we call as the integral form ன்னு சொல்லுவோம். And this is what we call as the integral form. But neatல பாத்தீங்கன்னா we have got questions based on a special case of that differential relation பார்க்கலாம்னு சொல்லிட்டு. So what is the differential relation we are having? Minus f dot dr is equal to what? Du, change in the potential energy. Okay. So இப்போ the special case என்ன தெரியுமா? If you are looking at the cases like, you know, there is an object at rest and a force is acting on it to cause the displacement. இப்போ இந்த மாதிரி கேஸ்ல என்ன தெரியுமா? The force and displacement will be in the same direction. Force ஆகட்டும் displacement, they will be in the same direction. So if you consider the motion using one parameter. So one parameter னு சொன்னா என்ன தெரியுமா? This is like, you know, the motion along the x-axis. So all the things will be in terms of the variable x. அப்படி. If you consider motion along the one parameter, அப்ப என்ன தெரியுமா? So இங்க பாருங்க, f and dr will be in the same direction. So அப்ப என்ன ஆகும்? Minus f dr into cos 0. ஏன்னா because we are looking at force and displacement to be in the same direction. So angle between them will be 0. Is equal to what? So cos 0 எவ்வளவு 1. So minus f dr is equal to du. இங்கிலிருந்து என்ன வரும் பாருங்க? F will be equal to what? Minus du by dr. எப்படி? F will be equal to what? Minus du by dr. Okay. So எப்போ இந்த ரிலேஷன் நம்ம யூஸ் பண்ணலாம்? When the motion is related to only one parameter. Okay. அது x axis ஆகலாம், y axis ஆகலாம், whatever it is. So if the motion is related along the x axis வெச்சுக்கோங்க, then what we'll have? F will be equal to minus du by dx, because here the position will be along the x axis. Okay va? So like this we can write. So this is a special case of the relation. When we can use it? When the motion is just in one parameter, means an object starting from rest, it is moving under the influence of the applied force or the conservative force, which is along the x axis. Then the parameter will be only one. The entire motion will be only in terms of one parameter. Okay. அது x coordinate ஆகலாம் or y coordinate, maybe it is, or z coordinate. Okay. So அங்க நமக்கு என்ன ரிலேஷன் வரும்? F will be equal to what? Minus du by dr. Or if, say for example, the motion is along the x axis வெச்சுக்கோங்க, then it will be what? F will be equal to minus du by dx. In this, u is what? What is u? Potential energy function. u என்ன தெரியுமா? What is u? Potential energy function. Okay. In Anna, we can look at what is the graphical interpretation of this relation. What are we saying? For this conservative force depending on one parameter. So this is the case we are discussing. Okay, what is the relation? F is equal to what? Minus du by dr, or we can say minus du by dx, assuming that parameter is the x coordinate. Okay va? If you are having the potential energy function with respect to r or x, then the position. Okay, so it can be a curve. So if you have the curve, the du by dx, right? What is this graphical interpretation? Slope of the tangent drawn to the curve. What is du by dx? Slope of the tangent drawn to the curve. So minus du by dx and so now what is it? That is negative of slope of the tangent to curve. That represents the force. In the graph la namakku force verunu vechukonga. Eppadi adu force derive pandrathu? You at any point you take the slope of the tangent. அப்படியே negative பண்ணணும். So negative of slope of the tangent is what? The conservative force value. Okay va? So is the relation. This is the relation between the potential energy function and the corresponding conservative force. Main enna namakku இந்த இதுல இந்த questions varum where we have the potential energy and the conservative force depending upon one parameter. Like it will be usually enna x axis da irukum. Okay va? When we look at the significance of potential energy, will be, it will help us to understand what we call as the nature of equilibrium. Another, the significance of potential energy will be what? It will help us to understand the nature of the equilibrium. Okay, so this is a concept that we will discuss in translation motion, and the madri we will also discuss about this in the rotational motion. Okay, so rotational motion in the concept varum parunga. What is equilibrium? Equilibrium enna sonna theriyuma? In terms of the translation motion, equilibrium means the situation where the force is zero. Equilibrium sonna, what is it? The force acting on that object will be what? Zero. Other than that is what we call as what? Equilibrium. Okay, now when we look at these three cases, inga parunga, this case the object is static or at rest, means what? Force acting on that is zero. And the madri inga parunga, object is at rest, means force acting on that is what? Ingu zero dana. Inga parunga, what is the force acting on that object? Zero. So what you are seeing here, force acting on the object is zero here, zero here, zero here. So we will call them as what? All three will be what? Equilibrium and solla. All three are in equilibrium. Okay, but these three equilibrium, right, they are different nature. எப்படி ன்னு சொல்லிட்டு பார்க்கலாம். So look at this. இங்க left side ல இருக்கு தெரியுமா? case A ன்னு சொல்லலாம். This is going to be called as what? Stable equilibrium. Second case B என்ன தெரியுமா? We will call it as unstable equilibrium. Third case C, we will call it as a neutral equilibrium. எப்படி இந்த classification வருதுன்னு சொல்லிட்டு we will try to understand. Okay, so first என்ன? For all the equilibrium, right, net force acting on the object will be what? Zero. அப்போதான் அது equilibrium ல வரும். Okay, so equilibrium condition enna? The net force acting on the object should be zero. Okay va? Aprom, when you look at the potential energy value, right, inga parunga, when the object is here, the potential energy will be at the minimum level. எப்படி சொல்ல முடியும்? If you just give some disturbance, right, parunga, if you just give some disturbance, it will go to a higher level. அப்படிதானா? அங்கல நீங்க கொஞ்சம் டிஸ்டர்ப் பண்ணா what is happening? That object அங்கல it will go to higher potential energy தானா, which means what? The potential energy value in that equilibrium position is what? Minimum. Okay, அந்த மாதிரி இங்க பாருங்க, if you just give some disturbance to this, right, what is going to happen? இது அப்படியே பாருங்க, the potential energy value is going to become less. Equilibrium position landu konjam disturbance kudutha, what you are going to observe? The potential energy value is going to be what? Becoming lesser. So this equilibrium position, right, we are having the potential energy of that particular object maximum or highest. Okay, highest and solla, we can say it as what? Maximum. So in the equilibrium case A, anganadi the potential energy of the object is minimum. Inga parunga, the case B lenna, the potential energy of the object is maximum at the equilibrium position. Okay, case C lenna varudhu parunga, if you just give some disturbance to it, it will either go to the right side or left side. Is the potential energy changing? Inga potential energy and sonna we are talking about gravitational potential energy. Okay va? So if it is going on the horizontal surface, right, vertical level la separation varala, so the potential energy will remain the constant. The potential energy will remain constant. Okay, so ipo paakala, why are we calling this as the stable equilibrium? Why are we calling the case B as the unstable? Why are we calling the case C as the neutral? Okay, so parunga, case A, why we are calling it as a stable equilibrium theriyuma? Because when we are giving some disturbance, from the equilibrium position. இப்போ நீங்க கொஞ்சம் disturbance கொடுத்தா what is going to happen? The object, அதோட potential energy will be what? Increasing. Okay, so remember, anything in the universe, right, it always want to decrease the energy. It never wants to increase the energy. So nama konjam displacement கொடுத்தா its potential energy is decreasing, so it will have a tendency to go back. இதனால because in that equilibrium position potential energy is what? Minimum, right? So it will always have a tendency to go back. So நம்ம அங்கல இருந்து disturbance கொடுத்தா displacement கொடுத்தா the object will have a tendency to go back to the equilibrium position. அதனால we call the equilibrium as what? Stable. Stable ன்னு சொன்னா என்னது? நீங்க கொஞ்சம், so when you say somebody is stable, ஏதாவது disturbance வந்தா he will not get disturbed much, then you will say that person is very stable. அப்படிதானா? Same here. So if you are having, the displacement given to that object, it will come back. It will have a tendency to come back. Come back and சொல்றதுக்கு பதிலா we will say what? It will have a tendency to come back. So that is why we call it as what? என்னது? Stable equilibrium சொல்லுவோம். Okay. பட் இங்க பாருங்க, கேஸ் B ல பாருங்க. கேஸ் B ல என்ன? When you are giving some displacement to that object, அங்கல இருந்து நம்ம கொஞ்சம் displacement கொடுத்தா what is going to happen? It is going to move to a place where the potential energy is less. So what is happening? Potential energy of that object will decrease. இங்க என்ன தெரியுமா? அப்படியே அந்த ஆப்ஜெக்ட் போயிட்டே இருக்கும். It will keep going away from the equilibrium. Why? Because as it is going down, its potential energies keep on decreasing, right? Because anything in the universe always want to decrease the energy. Okay va? So நீங்க இந்த பக்கம் displacement கொடுத்தா அப்படிதான், it will keep going away. So இங்க என்ன தெரியுமா? The object, when we give displacement from the equilibrium position வந்து நம்ம displacement கொடுத்தா what is happening? The object is having a tendency to go away from the equilibrium position. அதனால we call it as what? என்னது? We call it as what? Unstable equilibrium. Unstable. கொஞ்சம் நம்ம disturb பண்ணி விட்டா it will keep going away. இங்க எப்படி வரும் பாருங்க. So we are moving it to the right or we are moving it to the left. Potential energy ல change இல்ல. So ஏன்னா because the object is on the horizontal level ல இருக்கா. So potential energy will remain constant, right? So இங்க என்ன தெரியுமா? There will be neither a tendency to move towards the equilibrium nor away. So நம்ம கொஞ்சம் displacement கொடுத்தா it will stay there only. So there will be no tendency to come back or no tendency to move away. Okay, so that is the nature of the neutral equilibrium. So என்னது பாருங்க, we have stable equilibrium. Stable equilibrium சொன்னா the potential energy of that object in that equilibrium will be minimum. Okay va? Unstable means what? Potential energy is maximum. Neutral will be when the potential energy function is a constant function. Constant function இருந்தா then that particular situation will be called as what? Neutral equilibrium. இதுக்கு mathematical significance என்ன தெரியுமா? When we say that potential energy is minimum or potential energy is maximum, பாருங்க, if you are having any function, so f of x ஒரு function வச்சுக்கோங்க, when that function is reaching maximum value, இது நம்ம basic mathematics ல இத பத்தி டிஸ்கஸ் பண்ணிருக்கோம். When the function is reaching maximum value or minimum value, when a function is reaching maximum value or minimum value, what is it? The derivative of that function. What is that? The derivative of the function. So f dash x will become what? 0. Graphically அதோட significance என்ன? It is the slope of tangent to the f of x curve. Other value it will become what? 0. So பாருங்க, like say there is a function வச்சுக்கோங்க, it is reaching a maximum or it is reaching minimum. பாருங்க, slope of the tangent எவ்வளவு வரும்? 0. So when it is reaching a maximum value or minimum value, what must be the condition? The derivative of the function with respect to variable. இங்க என்னது? We are talking about the how the potential energy is changing with respect to position. அப்படிதானா? So du by dr ஓட value, derivative of that potential energy function with respect to position should be 0. அது maximum case ஆகலாம் or it can be minimum. It can be maximum potential energy case or minimum potential energy case. Okay. When we are having the neutral equilibrium, அங்க the potential energy is constant. See, if you potential energy is constant, right, what is the derivative of a constant function? Adi 0 dana. What is the derivative of a constant function? Adi 0. So which means what? Their neutral equilibrium also, the du by dr value will be 0. So first enna functionally eppadi nama adu evaluate pandrathu? When you are having the potential energy function, the condition for equilibrium enna theriyuma? What is the condition for equilibrium? Adu stable equilibrium agala or unstable or neutral, whatever it is. The du by dr value another, it will become what? 0. So whether it is a stable equilibrium or unstable equilibrium or even neutral equilibrium, du by dr value will be what? 0. Adukana graphical significance enna parunga? The slope of the tangent that you take for the potential energy curve will be 0. So even in the neutral case la eppadi varum parunga? Neutral and sonna what is it? Potential energy is a constant function. Ipo parunga, constant function means what? Horizontal line dana. So நீங்க இந்த லைனோட ஸ்லோப் எடுத்தா what is it? Slope of a horizontal line is what? 0. The line on the slope எடுத்தா what is the slope of the horizontal line? 0. So அதனால even in the case of the neutral equilibrium also same condition. So this is the first condition. First condition enna? For the equilibrium. For the equilibrium, du by dr value will be 0. Okay. So the graphical significance enna? The slope of the tangent that you draw for the curve will be 0 for the stable equilibrium, unstable as well as neutral. Okay, moonuthu we'll have the same condition. If we look at how do we see the difference between them. Inga parunga, in case of the stable equilibrium nama enna sollirkom, the potential energy in that position will be minimum as compared to the neighboring points. So if a function is minimum, right, inga parunga, so if function is a minimum, the function is in terms of the variable position. Minimum condition enna theriyuma? Du by dr will be 0. Adu vannu. Second derivative for a function to be minimum, to have a minimum value, right, second derivative value should be positive or more than 0. If you have a function, what is the condition to check whether the function is having the minimum value, or that the first derivative should be 0? Means du by dr value should be 0. Second derivative should be positive. That is what is the condition for the function to have a minimum value. Okay va? Andha madri inga parunga, unstable equilibrium case la what is it? The potential energy is maximum as compared to neighboring points. So inga enna theriyuma, we are talking about the maximum condition. So adukku enna? First derivative 0, adu common da. Second derivative should be negative or less than 0. This is the condition for a function to achieve maximum value. Third then paranga, neutral equilibrium. Neutral equilibrium enna? Du by dr nama 0 nu sollirkom. Inga enna theriyuma? The potential energy is a constant function. So du by dr is 0, right? So paranga, potential energy u is equal to constant. Apadi nama edutha what is du by dr? 0. Ninga second derivative edutha what is it? That is also going to be 0. Here the function is a constant function, right? Inga enna iruka? Function is a constant function. Derivative of a constant function evala 0. Derivative of a constant function evala 0. Okay. See second derivative enna theriyuma? Already nama oru thara derivative eduthirkom, du by dr. Angala namakku oru expression varum. And the expression oda derivative nama edukanum. Adha second derivative nu solluvom. Second derivative nu sonna what is it? First nama du by dr edutha we will get a function, oru form varum. And the form oda derivative nama thirupi edukanum. Adha second derivative. எப்படின்னு சொல்லிட்டு we look at the examples, அப்ப நம்ம கரெக்ட்டா புரியும். Okay, so this is how we are going to analyze the equilibrium oda classification. Okay, ஏன் நம்ம இத டிஸ்கஸ் பண்ணிருக்கோம்னா, because in the last years, right, we have got, I think ரெண்டு தடவை வந்தது, we got the question on classification of equilibrium 2 times. எப்படி, how do we classify the equilibrium? First, whether it is a stable ஆகட்டும் or unstable or neutral, if they are giving us function கொடுத்தா what we are going to do? Put the condition du by dr is equal to 0. So அது stable equilibrium ஆகலாம் or unstable or neutral, எல்லாத்துக்கும் ஒரே condition. What is it? First derivative of that potential energy function should be 0. அப்புறம் if you want to classify as stable or unstable or neutral, அதுக்கு என்ன? If the second derivative is coming positive, இங்க பாருங்க, second derivative is coming positive means what? at that particular point potential energy function is achieving the minimum value. Okay, so that represents what? Stable equilibrium. Enga energy minimum irukko adha stable equilibrium. Okay va? If the second derivative is negative, means inga enna theriyuma, the potential energy is having the maximum value. The potential energy will be having the maximum value. Okay, so adana agum unstable equilibrium. If the potential energy is a constant function, see constant function or derivative, for ninga first derivative is 0, second derivative edutha adhum 0 da varum. So if the second derivative is also 0, adanadi neutral equilibrium. Neutral equilibrium and sonna adukana what is significance? Potential energy in the entire region will be constant function. That is neutral equilibrium. Potential energy in the entire region will be what? Constant function. Okay va? So this is how we will classify the equilibrium into stable, unstable and then neutral. இது எப்படி நம்ம graphically நம்ம analyze பண்றது பாருங்க. Here we are having a potential energy function with respect to the position. So R is what? Position. இங்க பாருங்க, we are marking points A, B, C, D நம்ம மார்க் பண்ணிருக்கோம். நீங்க சொல்லுங்க, what is this point A? See, point A is what? இது ஒரு horizontal line மாதிரி தானே இருக்கா? அந்த regionல what is the graph like? கிட்டத்தட்ட ஒரு horizontal line மாதிரி இருக்கா? What is it? At A, potential energy என்னது? Is constant. At A and சொன்னா the region surrounding A, அங்க the potential energy is like a horizontal line. அதனால this represents what? Neutral equilibrium தானா? So in a region, if the potential energy or the value is constant, means that is what? Neutral equilibrium. அப்புறம் இந்த point B and D பாருங்க, look at point B and அதுக்கப்புறம் point D. So point B எங்க இருக்கா? இங்க point D இங்க என்னது? The potential energy is reaching what? Maximum. So point A கிட்ட it is a constant value. அதனால it is becoming what? Neutral equilibrium. Point B and D, potential energy is maximum. Potential energy oda value என்னது? It is maximum. Okay va? So அதனால this represents what? When the potential energy is maximum, it represents what? Unstable equilibrium தானா? When the potential energy is maximum, it represents what? Unstable equilibrium. அப்புறம் இந்த point பாருங்க, point C. Potential energy இங்க என்னது? What is the potential energy? Minimum தானா? Potential energy is minimum. இங்க என்னது பாருங்க, potential energy is minimum. So it represents what? Wherever the potential energy is minimum, அங்க என்னது? The equilibrium will be what? Stable equilibrium. Okay va? So this is how we will be able to classify the equilibrium based on the potential energy function. Okay. So we'll go to one example question. அதுக்கப்புறம் we look at what is the question that has come in the NEET also. இங்க பாருங்க, this is the example question. The potential energy of a conservative force எவ்வளவு? U is equal to ax square minus bx. இதுதான் potential energy ஓட function, where a and b are positive constants. இங்க பாருங்க, a and b are what? More than 0. a and b ஓட values என்னது? Positive. Okay வா? Find the equilibrium position and discuss whether the equilibrium is stable or unstable or neutral. So இங்க என்ன சொல்லிருக்காங்க? First we have to find the equilibrium position. எப்படி find out பண்றது? For any equilibrium, அது stable equilibrium ஆகட்டும் or unstable or neutral, for any equilibrium, right? What is the relation we have? Derivative of the potential energy function. இங்க நமக்கு என்ன கொடுத்திருக்காங்க? They are giving us the potential energy function, right? Derivative of the potential energy function will be what? 0. So check பண்ணி பாருங்க, we have to take a derivative of ax square minus bx. So split பண்ணலாம், derivative of ax square வரும், அதுக்கப்புறம் minus derivative of bx வரும். Okay, so இங்க நம்ம எழுதலாம், a அப்படியே constant rate வெளியே வரும், derivative of x square minus b constant தான், derivative of x. இங்க பாருங்க, derivative of x square எவ்வளவு? 2x. derivative of x என்னது? 1. So what is this? 2ax minus b, இதுதான் derivative. அந்த கொடுத்த ஃபங்க்ஷனோட டெரிவேட்டிவ் என்ன 2ax minus b. So நம்ம கிட்ட கண்டிஷன் என்னது, if you are looking for equilibrium means what, the derivative must be 0 அதுதானா. so இப்போ நம்ம என்ன பண்ணணும், அப்படியே எடுத்துட்டு just equate the derivative oda value to be 0. equate பண்ணா அதுல இருந்து we will be able to find out what is the position where we will get the equilibrium. இப்ப பாருங்க 2ax oda value is b, அதுல இருந்து x oda value என்ன வரும், b by 2a வரும். so we are getting what is the equilibrium position. so எங்க வரும் equilibrium position, x is equal to what, b by 2a. so எங்க வரும் பாருங்க, x is equal to b by 2a. அந்த இடத்துல we will get what, equilibrium position. எப்படி, how do you calculate the equilibrium position சொன்ன உடனே first thing is what, அங்க கொடுத்த expression take a derivative எடுத்துட்டு equate to 0 அவ்வளவுதான். ஏன்னா what is the condition, first condition for equilibrium என்னது, whether it is a stable ஆகட்டும் or unstable or neutral. first condition என்ன, derivative of that potential energy function will be 0 அவ்வளவுதான். நம்ம ஈக்குவேட் பண்ணா என்ன வரும், அதுல இருந்து we will be able to find out what is the position where we have the equilibrium. okay, அது நமக்கு வந்தது. so what is the position where we have equilibrium, x is equal to b by 2a கிட்ட நமக்கு equilibrium வரும். ஓகேவா. so இப்போ அடுத்த ஸ்டெப் என்ன, they are asking whether that equilibrium is a stable one or unstable or neutral. அடுத்த ஸ்டெப் என்ன கேக்குறாங்க, they are asking whether the equilibrium is what, stable இல்லனா unstable or neutral. அது எப்படி நம்ம ஃபைண்ட் அவுட் பண்றது, செகண்ட் டெரிவேட்டிவ் வச்சு தான் நம்ம ஃபைண்ட் அவுட் பண்ண முடியும். அது எப்படி நம்ம ஃபைண்ட் அவுட் பண்றது, செகண்ட் டெரிவேட்டிவோட வேல்யூ வச்சு தான் நம்ம ஃபைண்ட் அவுட் பண்ண முடியும். எப்படி பாருங்க, செகண்ட் டெரிவேட்டிவ் சொன்னா என்னது, we have to take a derivative of this du by dx. the du by dx ஓட டெரிவேட்டிவ் நம்ம திருப்பி எடுக்கணும். okay, which means what, we have to take a derivative of du by dx ஓட வேல்யூ என்ன, 2ax minus b, right. பாருங்க இது நம்ம டெரிவேட்டிவ் எடுக்கணும். what is it, derivative of 2ax minus derivative of b. derivative of b ன்னு சொன்னா it's a constant derivative, right, 0. இங்க என்னது 2a வெளியே வரும். so 2a into derivative of x, what is it, வெறும் 2a மட்டும். this is what, second derivative. இப்போ பாருங்க second derivative value என்ன வருது, 2a வருது. already a is positive நமக்கு தெரியும், அவங்களே கொடுத்திருக்காங்க a and b are positive constants, means second derivative is coming what, positive. ஞாபகம் இருக்கா, what is it representing, when second derivative is positive, so first derivative is 0. அதுக்கப்புறம் second derivative ஓட value positive வந்தா what is that equilibrium going to represent, that equilibrium is going to represent what, check it guys, what is it going to represent, when the second derivative is positive, that means what, that represents the which position, maximum or minimum. check it and tell me what is it represents, maximum or minimum. correct இது நாம ஞாபகம் வச்சுக்கணும். ஏன்னா because if you are not clear with this, right, we will just end up picking the wrong answer. okay, so we have to be clear in terms of the condition for the maximum and minimum. திருப்பி நாங்க எழுதுறா பாருங்க. so the condition, so first condition எல்லாத்துக்கும் சேம் தான், for all the equilibrium, right, it is same. what is it, du by dx is equal to 0, that is same. second derivative, okay, second derivative oda value is a positive, means what, that represents minimum position, minimum for the potential energy. okay va, minimum potential energy சொன்ன உடனே what is it, stable. ஏன்னா every object wants to be in the minimum energy state, அப்படிதானா. if the second derivative is negative, that represents what, maximum position, which means it is what, unstable equilibrium. so இது என்னது, stable. இப்போ நமக்கு என்ன வந்தது, the second derivative is positive. second derivative is positive means what, we are in the minimum potential energy state, that is what, stable equilibrium. we are in the minimum potential energy state, means what is it, it is another, it's a stable equilibrium dana. so generally you have to check, you are saying unstable. you are able to get it now, why it will be stable, ஏன்னா நம்ம செகண்ட் டெரிவேட்டிவோட வேல்யூ பேஸ் பண்ணி தான் நம்ம சொல்ல முடியும். செகண்ட் டெரிவேட்டிவ் என்ன, it is coming as what, positive, right. second derivative positive means பாருங்க, so already நம்ம discuss பண்ணிருக்கோம். What is it? Second derivative value positive means what? That represents the function to be minimum. ஒரு function ஓட first derivative value becoming 0. That is the condition for both maximum அது the condition, minimum அது the condition. But அதுக்கு அடுத்த step என்ன? For the minimum point generally என்ன தெரியுமா, நமக்கு intuitively என்ன வரும்னா, okay second derivative positive means அது maximum ஆகலாம்னு சொல்லிட்டு we'll have that intuitive feeling. But அப்படி கிடையாது. Okay, ஏன்னா this will come based on how the slope is changing. இது எப்படி வரும்? This result, right, and the second derivative or result will come based on how the slope is changing. Okay va? So இப்ப என்ன பாருங்க, when you have the minimum, what is the condition for the minimum? Second derivative of the function should be what? Positive. That is the minimum condition. Maximum condition enna? Second derivative will be negative. If the second derivative is also 0 anichukonga, then it means what? That is representing what? Neutral position, where the entire region potential energy value will be constant. Adu change agadu. Okay va? Okay, good. So if we look at a question that has come in the 2012 paper as it is, I think totally 2 or 3 times this question has come, I mean in the model question based on the equilibrium. What they are asking us, neenga solve pannala. The potential energy of a particle in a force field is what? U is equal to A by R square minus B by R, where A and B are positive constants. Inga padda, A and B are what? Positive constants. Okay, idukku onku difference irukka? See, previously what is it? Ax square minus bx. Inga enadi A by R square. Inga enadi R square is coming in the denominator. Adha madiri second term lo R is coming in the denominator. A and B are constants. R is the distance of the particle from the center of the field. Okay, so R represents what? Position. Okay, for the stable equilibrium, the distance of the particle is, means for the stable equilibrium R oda value evla, adha ungalku kekkradhu. What they are asking us, for the stable equilibrium, right, what is the value of R? For the stable equilibrium, what is the value of R? So first thing enna, whether it is a stable equilibrium agatum or unstable equilibrium or neutral equilibrium, right, first thing is what? The derivative of this function with respect to variable. What is the variable here? Position R. Other value must become 0. That is the condition. Okay, paranga, what is the derivative of this function? A by R square means we can write it like what? A into R power minus 2. Appadina meludala. B into R power minus 1. Inga paranga derivative. So first term derivative enna varum? A into, it's like what? Derivative of x power n evla? N into x power n minus 1 dana. So paranga, minus 2 into R power minus 2 minus 1. Adukapram we'll have minus B into minus 1 R power minus 1 minus 1. So idanadi minus 2A by R cube, minus minus become plus, plus B by R square. Is the derivative of the value. So this is what? The derivative. What is the first derivative of the value? Minus 2A by R cube plus B by R square. Paranga, what is the derivative? Minus 2A by R cube plus B by R square is the derivative of the value. Okay, so inga nam eludala, what is it? The first derivative of the value enna? Minus 2A by R cube plus B by R square. Ipo nam enna pananum? We are looking for what? Find the equilibrium, right? Eppadi find out pandrathu? The first derivative of the value, it should be 0, right? Which means what? Minus 2A by R cube plus B by R square is 0. Adana. So paranga ninga idu left side edutittu vanda, it will be what? Plus side. 2A by R cube is equal to B by R square. Idhula oru R square cancel panna, what you will have? 2A by R is equal to B. 2A by R evala B. Okay, so igala what is the value of r going to come as r எவ்வளவு 2a by b வரும் பாருங்க. What is the value of r we will have 2a by b. Okay, so இங்க என்ன தெரியுமா, because see நமக்கு என்ன வந்தது, we are getting the point of equilibrium. What is the value of r here? 2a by b. இதுக்கப்புறம் என்ன தெரியுமா, we have to conclude whether the equilibrium is a stable இல்லைன்னா unstable சொல்லிட்டு நம்ம கன்க்ளூட் பண்ணணும். பட் ஆல்ரெடி அவங்களே சொல்லியிருக்காங்க. அவங்களே என்ன சொல்லியிருக்காங்க, stable equilibrium. For the stable equilibrium the distance of the particle is. நம்ம first derivative வேல்யூ 0 ஈக்குவேட் பண்ணா அதுல இருந்து if you are getting multiple, ஒரு சில இதுல என்ன ஆகும் தெரியுமா, we will be able to get multiple values of r. We will be able to get what? Multiple values of r. நீங்க அந்த first derivative ஓட expression 0 ஈக்குவேட் பண்ணா we will get what? Multiple values of r. அப்போ we will have to confirm எங்க stable equilibrium வரும் இல்லைன்னா எங்க unstable equilibrium வரும்னு சொல்லிட்டு. If you are having multiple values of r அப்படி வந்தா then ஒரு இது எடுத்துட்டு we have to confirm whether the equilibrium is a stable one இல்லைன்னா unstable ன்னு சொல்லிட்டு. அது எப்படி நம்ம கன்ஃபார்ம் பண்ண முடியும்? We have to go and check the second derivative. எப்படி நம்ம செக் பண்ண முடியும்? We have to go and check the second derivative. இப்போ ஆல்ரெடி நம்ம கிட்ட first derivative function இருக்கா? What is it? minus 2a by r cube plus b by r square. So இப்போ இதோட டெரிவேட்டிவ் நம்ம எடுத்தோம்னு வெச்சுக்கோங்க, that is what we are calling as second derivative. அதுதான second derivative. So based on the second derivative, இப்போ second derivative ஓட வேல்யூ பாசிட்டிவ் வந்தன்னு வெச்சுக்கோங்க, that is what, when the second derivative is positive, that represents what? Minimum position. Potential energy minimum is what? Stable equilibrium. When the second derivative is negative, when the second derivative is negative, that represents what? Maximum position. Maximum means what? Unstable. Okay, so adu base panni we will be able to conclude whether the equilibrium is a stable one illana unstable nu sollitu. Okay va, but inga enna theriyuma, namakku and confusion illa. Ena because we are getting only one value for r. inga enna varudhu paranga, we are getting only one value for r. Okay va, so what is the thing that we can say from here? Because we are getting only one value for r, right? And they are themselves saying stable equilibrium sollitu, and the option liyum none of them nu sollitu or option illa. So if there is an option like none of them, அப்படி இருந்தா we will be thinking, but inga none of them கிடையாது, which means what? The answer that we can safely tick is what? 2a by b. நம்ம கன்ஃபர்மேஷன் பண்ண தேவையில்லை, புரியுதா? So that will actually save our time. எப்படி நம்ம கன்க்ளூட் பண்ணிருக்கோம், because we are getting r is equal to 2a by b. அதுதான் நமக்கு வந்தது. அடுத்த ஸ்டெப்ல என்ன, we have to confirm. ஏன்னா அவங்க என்ன கேக்குறாங்க, what is the stable equilibrium position கேக்குறாங்க. So we have to confirm whether and the r is equal to 2a by b oda position, right? Whether it is a stable equilibrium position illana unstable anu solittu nama confirm pananum. Adu eppadi paranga, so if we want to do it right, what you need to do, we have to take a derivative of this function minus 2a by r cube plus b by r square. This is our second derivative. இது செகண்ட் டெரிவேட்டிவ். இப்போ பாருங்க, இது நம்ம எப்படி எழுதலாம், minus 2a into r power minus 3 plus b into r power minus 2 அப்படி நம்ம எழுதலாம். ஓகே, அடுத்த ஸ்டெப் என்ன, we have to conclude this differentiation. So minus 2a வரும், minus 3 into r power minus 3 minus 1 plus b into minus 2 r power minus 2 minus 1. So idana varudhu, minus minus becomes plus. So 6a by r power 4 minus 2b by r cube. This is the second derivative. Enadhu 6a by r power 4 minus 2b by r cube. This is the second derivative. Ipo enna theriyuma, and the second derivative kulla, second derivative and the term kulla we have to substitute our r value. But namakku vanda r value evla 2a by b, right? And the 2a by b value nama substitute pananum. r is equal to 2a by b நம்ம substitute பண்ணணும். substitute பண்ணா we can confirm. பாருங்க, substituting, this is what is a second derivative function, d square u by dr square. Substitute in the function குள்ள we have to substitute r is equal to 2a by b. அப்படி substitute பண்ணா அதுலேருந்து நமக்கு தெரியும் whether the equilibrium is a stable one இல்லைன்னா unstable or a neutral ஆன்னு சொல்லிட்டு. ஸோ பாருங்க 6a by r power 4. R power 4 means what? 2a by b whole power 4 minus 2b by r cube. R cube and what is it? 2a by b whole cube. இங்க பாருங்க, this is like what? 2 power 4 means what? 16 dana. So 16 a power 4 by b power 4. So what will have? 6a by 16 a power 4 by b power 4. இதுல என்ன தெரியுமா? ஒரு a cancel ஆயிடும். So 2 3s are 2 8s are. So என்ன வருது பாருங்க, இதுக்கப்புறம் just more mathematical simplification அவ்வளவுதான். So இது என்ன? 3b power 4 by 8a cube. அதுதான் first term. இப்போ second term பாருங்க, second term இது என்னது? 8a cube by b cube. So 2 1s are 2 4s are. b cube numerator போய்டும். What is it? b power 4 by 4a cube. Okay va? So what is it? 3b power 4 by 8a cube. அதுதான் first term. Second term என்ன? b power 4 by 4a cube. So இப்போ நம்ம இது conclude பண்ணலாம். What is it? If you take an LCM means it will be what? 8a cube, right? LCM is what? 8a cube. Okay. So இதுல என்ன? 3b power 4 minus 2b power 4 வரும். That is totally b power 4 by 8a cube. அதுதான் நம்மளோட second derivative value at that r is equal to 2a by b. இங்க பாருங்க, already நமக்கிட்ட என்ன information இருக்கா? a and b are positive constants. Means b power 4 will be constant, a cube will be constant. அப்படிதானா? b power 4 and they both will be what? Positive. So the second derivative is coming positive. Second derivative positive means what? The potential energy function is minimum. Adana second derivative positive means what? Potential energy function is minimum. So whenever potential energy of a function is minimum, right, that represents what? Stable equilibrium. Okay. So in the particular steps neenga panna, you will be spending some time. Okay. You will be spending some time to conclude that this is actually stable equilibrium. But na sonna madri, because we are getting only one value for r, right? And already avangale solranga stable equilibrium solittu. There is no option like none of them. So these are generally what we call as the shortcut and solla mudiyadu, but this is the way in which you can actually save the time. Okay, options la none of them irundha we have to be careful, but none of them kudukala vechukonga, then we are getting r is equal to a baby ore value da varudhu. They are saying stable equilibrium means what? That point must be corresponding to stable equilibrium only. Okay, அப்படி conclude பண்ணி we can just tick the option as B and then move on. So ஏன்னா நீங்க அந்த second step பண்ண மாதிரி இருந்தா it is taking lot of time பாருங்க. So to prove that it is a stable equilibrium, அதுக்கு நம்ம என்ன பண்ணணும்? We have to take the second derivative எடுத்துட்டு we are seeing that second derivative is coming positive, means and the potential energy of the function is reaching minimum at the point. That is why we are able to say it is what? Stable equilibrium. Okay va? So this is how we will have to solve problems like this. Konjam time edukkum indha madiri problems, but if you are getting means we should be ready to solve. Konjam practice panna we will be able to speed up. Okay, so this is what is the concept of the potential energy and the relation of the potential energy to the conservative force. Other than generally, right, we will use this word mechanical energy and solid. Generally we will use what? Mechanical energy. So mechanical energy means it is a general word that people use to represent the kinetic energy and gravitational and spring potential energies. And mostly in mechanics, right, namak enna energy terms varum? Kinetic energy varum. Andha madri gravitation and potential energy varum, spring potential energy varum. Okay, so this set of energy terms, right, ella sethi we call it as what? Mechanical energy and solluvom. Okay, so when we say mechanical energy of an object, right, what are we talking about? On the object of the kinetic energy plus the gravitational potential energy irunda the spring potential energy. Okay, but maximum case you will either have this or this. So this is what we will be referring to as what? Mechanical energy and solid. This is what we will be referring to as what? Mechanical energy. Idoda significance enna theriyuma? In the modified work energy theorem. What is the modified work energy theorem? Work done by all the non-conservative forces and other external forces. Work done by all the non-conservative forces and other external forces is equal to what? Change in kinetic energy plus change in potential energy. Change in potential energy sonna we will have what? The gravitation irukum. If there is a spring means you will have spring also. Okay, so inga parunga, change means what? Ke final minus Ke initial. Inganadi P final minus P initial. Potential energy can be spring potential energy or it can be gravitational. It can be both also. Render in the what you will do? There will be spring potential energy taniya varum, gravitation potential energy will come separately. Okay, so inga parunga, what you will be having? The Ke final plus Pe final. அது ரெண்டு ஒரு சைடுல நீங்க போட்டா minus K initial plus P initial. So if you look at the modified work energy theorem, right, the work done by the non-conservative forces and other external forces, அதோட value என்ன? That is K final plus P final minus K initial plus P initial. Okay, so we are going to discuss about one important concept here. If the work done by the non-conservative forces and other external forces is zero, if work done by the non-conservative forces and other any external forces is zero, what you will get? Left hand side is zero, is equal to what? K final plus P final minus K initial plus P initial. பாருங்க, இந்த நெகட்டிவ் டேர்ம் நம்ம லெஃப்ட் சைடு எடுத்துட்டு வரலாம். What you will have? அது பிளஸ் சைடு. K initial plus P initial is equal to what? K final plus P final. இது என்ன தெரியுமா? This is what we will be referring as the conservation of total mechanical energy. What is the condition we will refer to as conservation of total mechanical energy? இது எப்போ வரும்? When the work done by the non-conservative forces and any other external forces acting on the body is zero nechkonga. Then what we will have? We will be having the initial kinetic energy plus potential energy value, right, will be equal to final kinetic energy plus potential energy, which means initial total mechanical energy. Mechanical energy சொன்னா what is it? Kinetic energy plus potential energy terms. Potential energy la we are not referring to electrostatic, adalla varadu, only the ones that we use in mechanics. What are those? Gravitational potential energy and then spring potential energy. Okay va? So the sum of initial kinetic energy plus potential energy of the objects will be equal to what? The sum of final kinetic energies and initial potential energies. This condition is what we will call as conservation of total mechanical energy. இது எப்போ applicable ஆகும்? When the work done by the non-conservative forces and other external forces acting on that body is zero வச்சுக்கோங்க. Then in that case we will use the condition of conservation of mechanical energy. What do you mean by condition of conservation of mechanical energy? Initial state la irukra kinetic energy oda value plus potential energy value will be equal to what? Final state la irukra kinetic energy and potential energy. That is what we will refer to as what? Conservation of total mechanical energy. Purida? So this is what is the idea of what is the mechanical energy, and mechanical energy ஒரு சில இடத்துல we will see this statement. So mechanical energy ன்னு சொன்னா ஒண்ணும் கிடையாது. It is what? Generally whatever the energy terms we use in mechanics, which is a kinetic energy term வரும். Potential energy la we will refer to what? வெறும் gravitational potential energy and then spring potential energy. The total of these three terms is generally called as what? Mechanical energy ன்னு சொல்லுவோம். Okay, அதுக்கப்புறம் when there is no work done by the non-conservative forces or the external forces, work illana, then the total mechanical energy of that object will be conserved. Okay va? So this principle is important. ஏன்னா நம்ம applications ல பார்க்க போறோம். When we go to the applications of the work energy theorem, right, adula we will see lot of problems where we will be using this conservation of total mechanical energy principle. This is generally called as what? Conservation of total mechanical energy principle. எப்போ இதை யூஸ் பண்ண முடியும்? When the work done by the non-conservative forces and other external forces is zero, அப்போ நம்ம இந்த result யூஸ் பண்ணலாம். ஓகேவா? So அடுத்த question பாருங்க. This is a question that has come in the Karnataka paper 2013 NEET. Okay, so this is the different question. அதனால we are trying to discuss it. Okay, a particle with total energy E, and the particle total energy எவ்வளவு? E is moving in a potential energy region Ux. இங்க பாருங்க என்ன கொடுத்திருக்காங்க? potential energy ஓட வேல்யூ கொடுத்திருக்காங்க. or term, what is it? Ux. total energy எவ்வளவு? E. Okay, motion of the particle is restricted to the region when, அவங்க எடுத்த region, whatever the region they are taking, right, இதுக்குள்ளதா the motion of the particle should be restricted. Okay, the motion of the particle should be restricted to that region. What is the condition? So option A பாருங்க, u less than E ன்னு சொல்றாங்க. option B ல u is equal to 0. option C, u is less than or equal to E. option D ல என்ன? u is more than E. சொல்லுங்க, what is the answer for this? இது எப்படி தெரியுமா? why I taken this question? This is a little bit I mean it's not like a regular question மாதிரி கிடையாது. எப்படி நம்ம சொல்ல முடியும்? see, when we can say that the motion of that object is restricted to a region. so இந்த நம்ம எடுத்த region குள்ள தான் motion இருக்கணும். வெளியே போனா, இந்த regionக்கு வெளியே போனா motion இருக்க கூடாது. means outside no motion should exist. means நம்ம அந்த டிரா பண்ண பவுண்டரி குள்ளதா the object should be present. வெளியே போக கூடாது. அதுக்கான what is the condition பாருங்க. see, they are giving us what? total energy கொடுத்திருக்காங்க, potential energy function இருக்கா. what is the kinetic energy term? what is the kinetic energy? actually the potential energy plus kinetic energy is total energy, right? total energy is like our mechanical energy மாதிரி. kinetic energy plus potential energy is what? total energy. இப்போ kinetic energy ஓட வேல்யூ என்ன? total energy minus potential energy. kinetic energy ஓட வேல்யூ என்ன? total energy minus potential energy. இப்போ பாருங்க, when we say the boundary we are drawing should be the region where the motion should be restricted, அந்த region குள்ள தான் இருக்கணும். அப்படி சொன்னா, see, this region, right, kinetic energy should be always more than or equal to 0. ஏன்னா இப்போ பாருங்க, நம்ம அந்த region குள்ள we are putting the condition kinetic energy more than or equal to 0 ன்னு வெச்சுக்கோங்க. what will be the outside region? in the region தவிர outside what will be the thing that we will have? kinetic energy less than 0 வரும். kinetic energy less than 0 means what? because kinetic energy can never be less than 0, right? அந்த possibility வராது. so outside this நம்ம draw பண்ண boundaryக்கு வெளிய motion cannot exist. புரியுதா? so what is the condition? is the condition. so what is the condition that will restrict the motion to the boundary we are drawing? and the boundary kulla we are putting the condition. what is the condition? kinetic energy of the particle. இப்படி தான் நம்ம restrict பண்ண முடியும். so if you put the condition that in the boundary that you are drawing, என்ன kinetic energy oda value we are putting it as what? more than or equal to 0. அப்படி நம்ம எடுத்தா it means what? இந்த நம்ம draw பண்ண boundaryக்கு வெளியே போனா இதுக்குள்ள kinetic energy more than or equal to 0, right? வெளியே போனா what you will end up having? kinetic energy less than 0. அது பாசிபிளா கிடையாது. kinetic energy less than 0 possible கிடையாது. ஏன்னா because kinetic energy will be what? always non negative, half mv square. அது நெகட்டிவ் ஆகாது. so outside போறதுக்கு there will be no scope. so when you put the condition kinetic energy of that particle is more than or equal to 0 inside the region, in the region kulla what is the condition you are putting? kinetic energy more than or equal to 0. பாருங்க, what is the kinetic energy relation E minus Ux is more than or equal to 0 means E இது நம்ம ரைட் சைடு எடுத்துட்டு போனா minus will become plus. E is more than or equal to Ux, or we can say Ux is less than or equal to E. இப்படி சொல்லலாம். Either E is more than or equal to Ux or Ux is less than or equal to E. Okay va? So this is what is the condition for which motion of the particle is restricted inside the region. And நம்ம எடுத்த boundary குள்ள தான் இருக்கும். ஏன் தெரியுமா? What is the please understand what is the condition we are putting here. We are putting the condition that the kinetic energy inside the boundary is what? More than or equal to 0, which means outside pona it means what? Kinetic energy is less than 0. Adu possible kadiyadu. Kinetic energy can never be less than 0, right? Adanal that condition is not going to exist, which means and the particle of motion is only inside the boundary. Adukku nama use panna condition enadhi kinetic energy of the particle inside the boundary is more than or equal to 0. And the condition நம்ம யூஸ் பண்ணா அதுல இருந்து நமக்கு வர ரிசல்ட் என்ன? Ux ஓட வேல்யூ should be less than or equal to E. அதுதான் condition. That is the condition which can restrict the motion of the particle inside the region. ஓகேவா? So இதோட நம்ம முடிக்கலாம். Next session என்ன? We'll start with the applications of the work energy theorem. So இதுல நிறைய cases வரும். Like we'll start with the applications of the work energy theorem in kinematics related problems. அதுக்கப்புறம் we'll talk about spring related problems. அதுக்கப்புறம் தனியா நான் ஆல்ரெடி சொன்ன மாதிரி தனியா we'll discuss about the vertical circular motion. அது ரொம்ப இம்பார்ட்டன்ட். ஏன்னா நிறைய தடவை அதுல இருந்து क्वेश्चंस வந்தது. Okay, so we'll talk about the applications of the work energy theorem starting from the next session. Okay, we'll see in the next class.